Refraction of light. Bending of light is nothing but refraction of light. Does all bending of light produces a refraction of light? I don't think so, right? See, students, you have to understand one point. When there is only one medium, then this light travels in a straight path. So, refraction of light can be defined as bending of light from one medium to another medium. Okay? So, that is when incident light. See here, there is two medium. One is air and the other one is glass. So, when a ray passes from air, it strikes glass slab and it bends, gets refracted. I is greater than R. Now, my question to all students is that why this light bends? So students, this is an assignment for tomorrow. You have to answer my question immediately after you watch this video. Now, let's move on. Now I want to know in which direction this light bends. When it travels from air, let us take this air as a rarer medium, this glass as a denser medium. Rarer denser means this is less dense, this is high dense. So, when light travels from rarer medium to denser medium, now what happens when light travels from the rarer medium to denser medium? See, as you can see, incident ray falls on this slab, that is when a ray was in rarer medium, then it passes through the glass slab, it is a denser medium. So here the angle of incidence is this, angle of refraction is this. Now my question is, which direction will light bend? As you can see, here is a incident ray, is a refracted ray. Now tell me which direction. Let us see that while it is in the air, angle of incident is I, and when it is get refracted, the refracted ray is given by R. So you can see it bend towards the normal. See, this is a normal line, right? So which direction will light bend? The light bend towards the normal. As you can see, it bends towards the normal when light travels from rarer medium to denser medium, right? Now let's see the other case. Now what happens when light travels from denser medium to rarer medium? So now the light is over here. Okay, now light travels from denser medium to rarer medium. What happens? Now what happens? So while light travels from denser medium to rarer medium, light bends away from the normal. As you can see, it bends away from the normal. So when light travels from rarer to denser, it bends towards the normal. When light travels from denser medium to rarer medium, it bends away from the normal. Away from the normal. So students, keep in mind, why this happens is air is less dense, light travels from dense, very light dense. Density of air is less than that of density of glass. That is the reason why it bends towards normal. The case here, density of glass is more than density of air. Therefore, light bends away from the normal. Now, next is laws of refraction. We had seen laws of reflection. I think everyone knows the laws of reflection. The incident ray, reflected ray and normal at the point of incidence all lie on the same plane. angle of incidence is equal to angle of reflection. This is the laws we have learned about reflection. Now we will be learning about laws of refraction. So what first law says is, it's very similar. The incident ray, now it is not a reflected ray, instead we have a refracted ray, and normal to the interface, of two transparent media, at the point of incidence. All lie on the same plane. See, in case of reflection, you had seen the incident ray, reflected ray, and normal all lie on the normal at the point of incidence, all lie on the same plane. But in case of refraction, the incident ray, the refracted ray, and the normal to the interface of two transparent medium. So students, you can see this image, right? Here, this is the interface. So this is the interface, okay? So incident ray, refracted ray, normal at the normal to the point of interface. This is the interface of two transparent medium. Air is transparent, glass is transparent. I think you know it very well. At the point of incidence, all lie on the same plane. Here, what plane refers to? Is it a screen? Is it a glass slab? Or is it a paper I am writing? Be sure, students. So, let me tell you that. Here, same plane refers to my paper. Okay, in my paper refers to same plane. Okay. Next is the second law of reflection. Refraction. Second law of refraction. So, second law of refraction. It is nothing but the ratio of sine of angle of incidence to the ratio of sine of angle of refraction is a constant. Once again, I will repeat. Ratio of sine of angle of incidence to sine of angle of refraction is a constant for a light of given color and for a pair of media. So, second law states that ratio of sine of angle of incidence to ratio of sine of angle of refraction is a constant for a given pair of color and pair of medium. So it depends on color as well as the two medias. Like for the reflection to place, as I told, there must be two medium. One, because light travels from one medium to another medium, that makes refraction. So second law of reflection is also known as Snell's law. Snell's law. So, in order to understand this, let's demonstrate this with an example. Let's give some numerical values for I and R. Let us calculate sin I by sin R. So for the value of I 30 degree and R 19 degree, just go on. You have learnt trigonometric functions, right? Sine, cos and all. Here only requires sine. So have the value for sine 30. For sine 30, what is the value? Is 0.5, and sine 19 degree is 1 point. So for sine 30 degree by sine 19 degree, what you will get? Check out, you will get 1.5. For other values, let I be 45 degree and R be 28 degree. Now sine 45 degree by sine 28 degree, you will get 1.5. So this is the this shows us that the ratio of sine of angle of incidence to sine of angle of refraction is a constant. So if you give different values, you will get the constant answer. Okay. Now let's move on to the refractive index.